Most of us grow up believing something that feels so natural, so unquestionable, that we rarely even notice we believe it. Time flows. It moves forward quietly, steadily, like a river that never stops. Seconds turn into minutes, minutes into hours. Yesterday slides behind us. Tomorrow waits somewhere ahead. And right now feels like a thin moving edge between what has already happened and what has not yet arrived. At first, this feels almost too obvious to even talk about. You don't need physics to tell you that time moves. Your watch moves, your phone changes numbers, your body grows older, tea gets cold if you leave it sitting too long. These things feel like evidence stacked neatly in front of us. And if you sit in a quiet room and you just listen, you might even feel time moving, not hearing it exactly, but sensing it in the slow rhythm of your breathing, in the way shadows stretch across the floor as the sun shifts, in the way a thought begins and then fades into another thought. It feels continuous, smooth, reliable. But then something feels off. Not loudly off, not dramatically wrong, just slightly uncomfortable, like noticing a clock ticking in a room you've been sitting in for hours, suddenly realizing you don't remember when it started. Let's slow down for a second. Imagine you are holding a clock, not a fancy digital one, just a simple, ordinary clock with hands. You watch the second hand tick forward. Tick, tick, tick. It seems like the clock is measuring time. That's what we say. The clock tells time. But if we pause and we look carefully, what is the clock actually doing? It isn't measuring time directly. It's counting motion, tiny mechanical movements, gears turning, springs tightening and releasing. The hand rotates through space in equal steps. And we quietly assume that this motion matches something deeper, something invisible, something we call time itself. But the clock never touches time. It only performs movements that we have agreed to call seconds. This is where it gets uncomfortable. Because if every clock is just tracking motion, then time, as we experience it, might not be something flowing on its own. It might be something we infer from how things change. Now imagine removing every clock in the world, every watch, every phone, every computer timer, every heartbeat monitor, every pendulum, every swinging metronome, every device designed to tick, swing, or oscillate. Now imagine you are sitting in a perfectly silent room. No windows, no outside light, no sound, the air is still, nothing moves, you are floating perhaps so even your muscles are relaxed. No hunger yet, no tiredness yet, just stillness. Would time still feel like it's passing? At first you might say yes, of course it would. Time always passes. But try to picture it carefully, without changes, without motion, without events marking moments. How would you notice time moving? You might start counting in your head, 1, 2, 3, but now your counting becomes the clock. The moment you count, you create motion in your mind, you create rhythm, and rhythm gives the illusion of time passing. So maybe time, the thing we feel, is deeply tied to change, not a river carrying events forward, but something that appears whenever things move, transform, or evolve. Physicists didn't expect this, by the way. For a very long time, people imagined time as something absolute, something universal, something that flows the same way everywhere, for everyone, no matter what they are doing or where they are. It feels comforting to believe that, almost necessary. Because if time flows differently for different people, then reality itself starts to feel less solid. But then, experiments started whispering something strange. Imagine two people, one stays on Earth, the other travels very fast in a spacecraft, not fantasy fast, just extremely fast. Fast enough that the universe begins to behave differently around them. The traveler carries a clock. The person on Earth carries another clock. Both clocks are carefully built, perfectly synchronized before the journey begins. The traveler leaves, the traveler returns. And when they compare clocks, something feels wrong again. The traveler's clock shows less time has passed. Not broken, not damaged. It simply recorded fewer seconds. At first, this sounds impossible. Almost like saying two rulers measuring the same table could give different lengths, and both be correct. But experiments confirm it, over and over again, tiny differences sometimes, but real differences, measurable, repeatable, quietly undeniable. This is where the ground begins to shift beneath our everyday belief. Because if time were truly flowing like a universal river, every clock would ride that river the same way. Speed wouldn't matter, motion wouldn't matter, gravity wouldn't matter. But they do matter. Let's imagine something gentler. Picture two identical hourglasses filled with fine sand. One sits on a calm table. The other sits on a table inside an elevator that is slowly accelerating upward. Both hourglasses are flipped at the same moment. If you watch closely, if you could somehow observe them with perfect sensitivity, you would discover that the sand might not fall in exactly the same rhythm inside both hourglasses. The acceleration slightly changes how processes unfold. Gravity does something similar. Strong gravity slows the unfolding of events, not just clocks, everything, chemical reactions, atomic vibrations, the quiet ticking inside matter itself. Let's pause here, because this idea is easy to hear and difficult to feel. When physicists say gravity slows time, they do not mean clocks malfunction. They mean reality itself unfolds more slowly. If you stood near something extremely massive, a neutron star, perhaps, or closer to a black hole, your body, your thoughts, your heartbeat, every process inside you would continue feeling perfectly normal to you. You would sip tea, you would blink, you would think a sentence and finish it naturally. But someone far away, watching you from a safer distance, would see you moving slower. Not dramatically, perhaps, but measurably slower. And from your perspective, they would appear to move faster. This is where it gets deeply unsettling, in a quiet way. Because it suggests time is not a single stage where events happen. It suggests time is woven into the fabric of motion, gravity, and perspective. It behaves differently depending on where you are and how you move. Let's step away from stars and gravity for a moment. Let's return to something smaller, something calmer. Imagine you are watching ice melt in a glass of water. The edges soften. Tiny currents swirl invisibly as temperature differences slowly fade. Eventually, the ice disappears into uniform cool water. We instinctively call this the passage of time. Ice melting feels like time moving forward. But notice something subtle. The melting is actually about energy spreading out. The organized structure of ice becomes less organized. Molecules move more freely. The system drifts toward balance. Now imagine in your mind a film of the melting ice. You watch it normally. Ice melts. Water warms slightly. Everything feels natural. Now imagine running that film backward. Water molecules would spontaneously gather into rigid crystal patterns. Ice would rebuild itself. Temperature differences would appear from nowhere. The backward version feels wrong, not impossible according to basic motion, but deeply unnatural according to our experience. So we associate time with this direction, the direction where order dissolves into disorder, where neat patterns blur into randomness. But here is the strange part. If you look at the deepest laws governing tiny particles, they often don't care about forward or backward time. The equations describing their motion frequently work both ways. They don't strongly prefer ice melting over ice forming. And yet, the world we live in clearly follows one direction. Physicists still argue softly about why. Some think it has to do with the early universe, a time when everything was strangely ordered, allowing disorder to grow. Others think it is tied to how information spreads and becomes impossible to perfectly reverse. There is still uncertainty here, honest uncertainty. And that uncertainty is important because it reminds us that time, the thing we trust every moment of our lives, is not fully understood. Let's imagine something else. Picture the universe as a vast landscape, not a movie playing from past to future, but a landscape where every moment exists like locations across a terrain. Your birth is somewhere in that landscape. This present moment is somewhere else. Tomorrow's sunrise is another place entirely. You are not watching time flow past you. You are moving through this landscape, step by step, carrying memory like footprints behind you. This idea feels uncomfortable for many people because it suggests the future might exist in some sense, even if we cannot see it yet, not predetermined necessarily, but already part of the structure. And yet relativity, the theory describing motion and gravity, quietly hints at something like this. It treats time as another dimension woven together with space, not identical to space, but deeply connected. When you move through space, your movement slightly changes how you move through time, almost like shifting your path across a tilted surface. Let's slow down again. Imagine walking across a large, soft mattress. If you step in one direction, the mattress bends slightly under you. Your path curves gently. Now imagine the mattress represents space and time together, and massive objects press deep curves into it. When you walk near those curves, your path changes. Your motion through time shifts, not because something is pushing a clocky, but because the geometry of reality itself is shaped differently there. You don't feel this in everyday life because Earth's gravity is gentle compared to cosmic monsters like neutron stars or black holes. But even here, satellites orbiting Earth experience time slightly differently than clocks on the ground. Engineers must correct for this, or GPS systems would quietly drift off course. So your phone, when showing your location, is already trusting the strange truth that time does not flow equally everywhere. That's a quiet thought. Your navigation app works partly because time bends. Now there is another crack in our everyday belief that is even quieter. We think the present moment is universal, that there is one shared now across the universe, that if something is happening right now here, there must be a matching right now somewhere across distant galaxies. But relativity whispers otherwise. Imagine lightning striking two distant mountains at the same time, at least according to someone standing exactly halfway between them. Now imagine someone moving rapidly toward one mountain. From their perspective, the flashes may not appear simultaneous. One arrives first, the other arrives later, and according to the rules of physics, both perspectives are valid. So the idea of a universal, shared present moment begins to dissolve. What counts as now depends on motion, on viewpoint, on how signals travel. This means the universe might not agree on a single moving present. The present might be personal, local, observer-dependent. That is a strange sentence to sit with. If there is no universal present, then what exactly is flowing? Let's sit quietly with that question. Imagine sitting in a dim room, watching dust drift slowly through a thin beam of light. Each particle floats, turning gently, almost weightless. You don't see time passing directly. You see dust shifting, light moving, your own thoughts sliding from one idea into another. Everything you call time might be a story your brain builds, stitching together memories, comparing changes, predicting what might come next. Your brain never perceives time directly. It perceives change. It perceives motion. It perceives sequences. And from those sequences, it constructs the feeling of a flowing present. There is something humbling in that thought, because it suggests the most familiar thing in our lives might also be one of the most carefully constructed illusions. Not a false illusion, but a useful one. A stable way for consciousness to organize experience inside a universe where simultaneity is flexible and duration depends on motion and gravity. Sometimes I wonder if the universe had been built slightly differently, if entropy did not grow, if motion did not shape duration, would any creature ever invent the idea of time at all? Or would they simply experience patterns without arranging them into past, present, and future? I'm not sure. And physicists, if they are honest, are not entirely sure either. There are theories attempting to describe time as something emerging from deeper relationships between events. Some suggest time may not exist fundamentally, but appears when complex systems compare information and track change. Others still treat time as something real but inseparable from the structure of space and matter. Both views, in their own way, challenge the quiet certainty we carry when we glance at a clock and trust it completely. Because that clock, if faithful and precise, is only measuring how certain physical processes unfold in one particular environment, at one particular speed, under one particular gravitational pull. It is telling the truth, but only locally. And maybe that is why time feels so steady in daily life, because we live in a narrow slice of the universe where conditions change slowly enough to keep clocks mostly synchronized, mostly obedient. But the universe itself, at its edges, near massive stars, inside violent cosmic collisions, or across vast relativistic journeys, seems to treat time less like a river and more like a flexible thread, stretching, compressing, quietly rearranging itself depending on how reality is shaped. If you sit long enough with that image, a thread instead of a river, it begins to feel less like time is carrying us and more like we are tracing paths along something already woven into existence. And if that is even partially true, then every second you feel passing, every heartbeat, every drifting thought might not be the movement of time itself, but the movement of you through a structure that is far stranger, far quieter, and far less obedient than any clock has ever admitted. And if that structure can bend and stretch and disagree with itself about what now even means, then it makes you wonder whether the sensation you feel at this very moment, the sense that this instant is sliding forward into the next one, is something the universe is doing, or something your mind is gently, patiently constructing while trying to keep track of.